control security. So right now I'm writing the critical infrastructure security report. I'm actually doing all this, the intelligence collection for the state of Florida on critical infrastructure.
A Nephilim spider joining the monsoon banquet. She's caught a tiger butterfly. And he is utterly toxic. Butterfly predators need to learn this.
Like I was telling everybody in the crowd, you're kind of coming in at a later point in time. If you look in the announcements channel, if you're at home and you're watching, you will see the curriculum for tonight. If you're just walking in and don't have a packet, like my man over here, I will yeet one at him. Yeet. So, do you still want to talk about, okay, you're not good, okay. So, like I was telling everybody before we started, welcome to week 2 of Prepper Month. I hope last week we were able to successfully make a good argument as to why being prepared is not only, it's not a cartoon thing, but it's something that really happens. It has real life consequences, and it's something that you should absolutely do. If you want to jump on another warehouse run, I think somebody's doing one. I'd really like to see people calling out their warehouse runs. We tried to do one last week. I couldn't do it. It didn't work out, which is why Chris didn't hear from me, but we'll try and get more going. Next week is the 4th of July. No guild night. Enjoy being with your friends, your families, blowing stuff up, celebrating the independence of our country, and then eventual dependence on our federal government. So, yeah, after that, we are going to be getting into a talk on Meshtastic, which, oh, no?
Yes.
Oh, okay, he made R2-D2 noises at me, so,
The buttons have been successfully printed. The other 3
okay,
parts are
we have buttons.
in progress.
We have buttons. But yeah, so in 2 weeks, we're doing a 0 to Hero Meshtastic class. As a part of your dues, the temple is ordering a bunch of Meshtastic kits for guild members. If you are not a guild member and you want a Meshtastic kit, we'll try and put a link out there for you to be able to buy your own, and then you can come down here, set it up, learn how to configure it. Everybody's happy-dappy. So tonight, as I was explaining to everybody in the audience again, we are trying to do something new with ham radio. It used to be kind of almost a science mixed with an art. Now I would almost argue it's more art than science, but we can we can get into that at a later time. The way it used to be with ham radio is it was a purely physical hardware-based thing. So at the end of the day, and if you can't see the board, I'm sorry, but yeah, sorry. So at the end of the day, ham radio was, in the olden day, trying to figure out how to take electricity, or actually how to take voice, turn it into electricity, which then turns into radio frequency, which then turns into electricity, which then turns into voice out a speaker. And it used to be that there was a transmitter, and a receiver. And those were 2 different pieces of hardware. So the transmitter transmits, the receiver receives, and a lot of times the ham shack, which is where you have your ham radio equipment set up, would be asynchronous. So these would be kind of 2 different components in a ham shack, and then eventually we wisely created the transceiver, which is just like you'd find with a butt fang here, your Baofeng UVR5, or a more fancier radio. That would be an example of a transceiver. You don't need 2 separate components or pieces of hardware to do the job for ham radio. So back in the day, you speak into a piece of hardware, and through wires and boards and transistors, which we don't really use transistors anymore, a lot of things are FPG, like logic gate based or FPGA based or chip based, which kind of are inherently turned things into being software-based. Before that, it was all physical hardware-based. And when you really think about it, that's a hell of a thing to figure out how to accomplish, how to take voice, turn it into electricity, which then turns it into radio frequency, which is then caught by an antenna, turned back into electricity, and then put out, you hear voice through a receiver. That is, when you really think about the science of it, when you really think about the art of it, that's a hell of a thing to figure out how to do. So, as time has progressed, we've figured out how to make these radios smaller, more affordable, more available to people, but the hobby is still dying. And I would argue, and you can call me controversial, that the hobby is dying because a lot of these old bastards that are sitting up at the top won't lower the ladder down and teach people in a fun, engaging way how to do ham radio, how to do amateur radio. And I do think it's kind of a symbiotic thing where you're trying to bring people into your hobby that's dying out, but you're going to be a dick about it, and then you're going to complain at your ham radio meetings with other dudes that your hobby's dying out. And I just don't think that there's an epiphany about why the hobby's dying out. So the current way to get your ham radio license is to go to hamstudy.org or download the app. There's definitely, or buy the book on Amazon, the ARRL book on Amazon, and just stare at the questions until you get it. Or you can buy the book and go through like 500 pages of lecture until you get it. I would posit both of those methodologies just suck. I think they both suck. I will also caveat, that's how I learned. Trey and I got our ham radio licenses together the same day at DEF CON. It took him 1 try, it took me 4 tries. Fuck you. Yeah, but I do think that also does kind of say something. I'm a bad test taker, and also I was drunk as shit that day. I think Danny was also, he took his test drunk.
Yeah, it took me 3 drinks.
Yeah. I don't know who had the... I think that was the year of Planet 13 gummies. I don't think we were drinking that year. I think they're...
Oh, I was probably crossfaded.
Well, no, you were definitely... I can tell when you were crossfaded. But, okay, we're going off topic. So, what I want this to be, because if you've ever read The Hacker Ethic, one of the big rules of The Hacker Ethic is always yield to the hands-on imperative. I think it is infinitely better to learn by doing than by studying and talking about it and having your thumb up your ass. So while we can't really do tonight because the FCC in its infinite wisdom says it's illegal to transmit without a ham radio license, I will throw out there, and I'm going to say this often and loud, it is not illegal if you do not have a ham radio license to turn on a ham radio and listen. Not illegal. Not illegal at all. So I highly encourage you, whether you want to spend 20 bucks, go on Amazon and get a butt fang, and that's your ham radio, and you're using that during the hurricane, which we talked about last week. Noah Crank hand radios. So those hand radios, they can't transmit. They might only be able to access a certain amount of frequencies or a certain range of frequencies. Even if you don't have a ham radio license and you buy a butt fang, you will be able to listen in on a couple of different frequency spectrums. You'll be able to listen in on the VHF spectrum, which we'll go into on the packet tonight, and the UHF spectrum, which we'll go into on the packet as well. So you can take this packet home and cram with it, which, if that works for you, do it. But if we don't get into everything tonight, you can at least take that packet home and, at least kind of finish the job. Now, the spirit of intent for tonight is we study together, we talk about this together. I'm going to try and take as much of this knowledge as possible and turn it into an engaging discussion. Filled with stories of me electrocuting myself when I was in the Marine Corps, because my corporals fucked with me and told me to hold on to an antenna to make sure that it didn't go anywhere, and then they keyed the mic, and it burned me, and it sucked. So now you guys know, don't fucking touch the antenna whenever somebody transmits, because it's really gonna suck. Or if you're RJ, touch the, in fact, put the antenna in your mouth. I'm kidding. So don't do that, because then that would make me very sad, because then you'd hurt yourself. And I still owe you a book, and I feel bad about that. So until I don't feel bad about that, don't try and hurt yourself. And after I stop feeling bad about that, you're free game. You and your mouth are free game. So, yeah, that was done on purpose. That was done on purpose. So, like I said, we're going to try and get through as much as we can tonight. Then you can self-study, go home, touch on whatever we haven't touched on left. I am going to try and skip over some of the FCC rules, just because a lot of those rules are no duh, and try and touch on as much of the technical as humanly possible. We'll go through that together. There's a website that I put out there before, and I will put it out there again, that will allow you to do remote ham radio technician exams. And all you'd have to do is pay them $30. They will send the exam to a computer, and then you'd use your phone or something so they can proctor you. So, you know, you'd set up like a dual webcam situation or something, so that way they can proctor. You take the exam at home, and then you pass. You don't have to get up off your ass. Otherwise, there's plenty of organizations around in the Tampa Bay area, the Clearwater Amateur Radio Society, Hillsborough County Aries Races, which we might talk about later tonight, that will absolutely take your $30 and proctor your exam. However, I would argue, why leave your house? We did try. We'll try again next year to get exams going at the temple. Didn't work out that way, but you know, maybe that's something we can work on from this year to next year. So, if anybody has any questions, comments, concerns, manifestos, we will get started. So, page 1, or actually, yeah, we'll go to the first page, where it is going to discuss electrical principles. I would argue this is where you're going to want to focus. Electrical principles is where you're going to want to focus the most. A, because it's going to be the biggest pain in the ass on the exam. B, because understanding what happens when you key your radio and understanding things like attenuation, understanding things like the length of your antenna, the length of the cable going from your antenna to your radio, that's all stuff that you're going to be able to use in the field. And people that do cram with hamstudy.org, and you know, they just get the bare minimum to get something done, so that way they can pass their exam and go out in the field, they will set up an antenna in their backyard with 50 feet of SMA cable or 50 feet of coax cable, and then they're getting a crap ton of attenuation, or they're getting a crap ton of interference, and they can't figure out why they can't jump on the Ni4CE repeater, which if it sounds like I'm talking in Russian right now, I promise by the end of the night you'll understand what I'm saying. If you can't jump on the Ni4CE repeater and listen to these old bastards talk about their heart medication for 5 hours like they do, well, you would know that there is a specific length of cable that you are supposed to utilize with coax cable that, you know, again, if you knew what you were doing and didn't just cram, you'd be able to kind of figure that one out. So there are, and please feel free to scribble on this, write about how much I suck on this, whatever you got to do to survive. So there are 3 important concepts whenever it comes to electricity. So there's R, which is resistance. And that is symbolized by that ultramarines or omega symbol, whatever you want to call it, the ultra toilet. So anytime you see that ultra toilet looking thing, think resistance. Resistance is measured in ohms. You've got voltage, which is measured in volts. And if you ever think of how electricity works, you could think of resistance being a small hole in a wall, and voltage being a big old fat guy, and amperage, which is A, so your amps, or your current, So your current, which is measured in amps, are how many people are on the ass end of that fat guy trying to push him through the hole. That's really the best way I could come up with how electricity works. And it's funny and embarrassing because oftentimes I am the fat guy trying to be pushed through the hole. So that might be something that you remember, is the resistance is the size of the hole, the amperage or the current is how hard's being pushed, and the voltage is how fat the guy is. And the reason this packet is so fat is these are all of the questions that could be possible in the test poll. You'll get 30 of them. And they're in different sections, but you will get 30 of these questions. And again, the reason I'm trying to drive this home, hang on one sec, I'll put this over here so that way people can, yeah, that works. Okay. So whenever the exam asks, what is the electrical term for the force that causes electron flow? Voltage. Good? So the name for the flow of electrons in the current, or the electrical circuit, that's current. Again, just think back to the metaphor of the fat guy getting pushed through the hole. Now, a lot of times, and you can kind of bring this in with hardware hacking as well, the reason resistance is so important, and you need a lot of resistors in play, is let's say you've got a 9-volt battery, so 9 volts worth of battery, and this LED can only take 1 volt. So if I hook the battery up to the LED, what's going to happen? It's going to pop out. Yeah. Somebody say it's going to catch fire?
Fireworks.
Sure, fireworks. Yeah, so it's going to explode the LED. Now, of course, you could say, but Cochise, why don't you just use a 1-volt battery to hook up to your 1-volt LED? And I'd say, if that's just the only thing that's in your circuit, you are absolutely right. 1-volt battery, 1-volt LED, everything's hunky-dory. But what if also in your circuit is a 4-volt LED and a OR logic gate? So would 1 volt power a 1-volt LED? Will it power a 4-volt LED? No. So there's a couple ways we can do this. So let's say 9-volt battery. Let's say we've got a path here, that breaks off to there. Yeah, okay, I think that'll work. So what can we put in the way of these of this circuit right here? A, to complete the circuit, and B, so we don't pop our LEDs. We put resistors in play, and resistors are symbolized by little squiggly marks. So if you put enough resistors to be able to step down this 9-volt battery, you won't pop your circuits. And you could customize them depending on where you are in the circuit, and everybody's having a very good hunky-dory time. So I want you to remember R for resistance, and this is going to be dumb, I for current, I for current, and E for voltage. It's stupid, I don't know why they do that, but as far as math is concerned, that's just how they do. I can tell you that current is measured in amps. So there is the current of this circuit right here, which is measured in amps, and the voltage, which is measured in volts, which no shit. And then you've got the resistance measured in ohms. And that's that. So if, for instance, you are trying to take a mobile radio, which if you've never seen a mobile radio, it's like a small rectangular shaped radio. You can put it in your truck, you can put it in your car or whatever, and hook it up to a 12-volt battery. Do you think you're going to need fuses in the way? Do you think you're going to need to step down that voltage? Do you think, and oftentimes radios do come with stuff that allows you to step down voltage, but if you buy anything that is not a handheld radio, a lot of times if you order a mobile radio or a big radio, you are going to get just something that you pull out of the box, and it's got a black wire and a red wire in the back of it. And that's oftentimes all you're going to get, and you're going to be like, what the fuck is this? So the thing with ham radio, because again, it is science, and the people who make these ham radios expect you to know this stuff, is they are going to expect that you're going to choose what kind of power source you want to use. You could choose a car battery, you could choose a solar panel, you could choose a power supply, and in fact, my ham shack uses an old analog power supply. So if you have a power supply and you know how much electricity that your ham radio can take, and you also know that the power supply can generate from 1 volt all the way up to, let's say, 20 volts, do you think after paying $500 for a ham radio, for a mobile ham radio, you're going to want to get that voltage correct and you're going to want to get those amps correct? Abso-freaking-lutely. You are going to want to get that power information correct. So that's where knowing what your power source can do and also knowing how much your radio can take is a good idea. So there's 2 kinds of currents. There's alternating current, there's direct current. I'm sure we've heard the Boomer song Shoot to Thrill by AC/DC. You can at least memorize that. A direct current looks direct. An alternating current alternates in how it pulsates. So if we looked at T5A09, which of the following describes alternating current, does everybody agree why it makes sense that it's a current that alternates between positive and negative directions? Do we think that it gives that one away, right? And if you look at a current that alternates between positive direction and 0, that doesn't make any sense. As far as picking the direction that current goes or picking the direction that electricity flows, it's going to flow through the circuit. It's not going to pick any specific direction. It will take the path of least resistance, but as far as electricity goes with direction, it goes where you tell it to go. So current that alternates between positive and negative directions. So I guess more what I mean by that. Okay, I can see how that would be confusing. So whenever you see the answer 0, so current that alternates between a positive direction and 0. 0 what? 0 what? So, but does it say volts? It just says current. So that would be amps, but it's not bringing up 0 amps. It's not bringing up any unit of measurement. So whenever you just see 0 without a unit of measurement, you know that's bunk. Good? What describes the number of times per second that an alternating current completes a cycle? Okay, so now we are getting into power and radio frequency. So the term RF, whenever you see RF, is radio frequency. Whenever you see frequency, think of waves. So we have a wave right here, right? So with a radio wave, or even let's take a radio wave for instance. If you take one cycle of that wave, so a cycle would be where it crests and where it falls. And you would compress that into a specific time. You'd have how many times, like for instance, depending on how fast a wave is moving, how often does it go up and down per minute or per second? A lot of times, at least with trying to figure out a baud rate in hardware hacking, it goes off of per second. And to me, it would make sense as well that a radio frequency is also going off of per second. So you are trying to figure out with a radio frequency, how many times does that wave go up and down per second? How many cycles? This is called a cycle. Lock that into your brain. So how many cycles are there per second? So if I say I have a radio frequency of 144.50, what does that tell us?
Goes up and down 144.5 times.
Bingo. Bingo. So that's all that means. And so, yeah, that's pretty much the definition of radio frequency. Now we're going to get into hertz. Say again?
1 cycle per second.
Well, kind of. Hertz is essentially, don't overcomplicate it. Hertz is just how frequency is measured. That's the best way that I could explain that one. And if you look at measuring things in henries, that doesn't make any damn sense. Measuring things in farads, that doesn't make any sense. Measuring things in Tesla doesn't make any sense. We've all heard of of radio being measured in hertz, right? To me, I look at that question and I just see a word that I've seen before. So just by process of elimination, that can be hertz. Whatever you've got to do to memorize that, Hertz donut, I've heard that one before, the rental truck service, whatever the hell. So yeah, radio frequency is measured in hertz. So if we are measuring units of electrical resistance, that is measured in ohms. Ohms also look like the omega symbol, which looks like a toilet. So if you want to associate the toilet with resistance because you had like a lot of food to eat that had cheese in it, hopefully you don't forget that. So you're associating ohms with resistance. Ohms, the O in ohms kind of looks like the omega symbol. You can associate omega with ohms because they both start with O. Couple of ways to do that, but resistance is measured in ohms. What type of current flow is opposed by resistance? Direct current, alternating current, RF current. Those are all correct because if you look at direct current and alternating current, if I put a resistor in the way of direct current and alternating current, the resistor doesn't care. So a resistor is often made of materials, like for instance, if wires are made of what are called conductors, or conducting material that makes the flow of electricity easier. Who here grew up watching Pokemon? Okay, so a decent group of people. Whenever Ash first gets Pikachu, and Pikachu shocks the ever-loving dog shit out of him, what's the first thing he gets out of his backpack? Who can remember this?
Gloves.
Rubber gloves, right? His mom gives him rubber gloves to do his laundry. God, you guys had a shit childhood. So, yeah, rubber is a good example of a resistor. Yeah, okay, you guys don't remember that because you guys are like 50, but whatever. Oh, okay.
Drink from the water hose too.
Yeah, right. Drink from the water hose in Flint, Michigan, or whatever. So things like rubber are good resistors. I think cadmium is a good rab. What's another good material? I think cadmium, right? Cadmium resists.
I mean, vinyl, various
Yeah,
fabrics,
yeah. Rayon. I think rayon resists.
even like water with no electrolytes in it is somewhat of a resistor.
I mean, it's not a good resistor, but it's kind of a resistor.
Not as bad as people think. It's when it gets all salty that it gets bad.
Yes, salt water because it's got electrolytes. I think that word electrolytes kind of throws out that it has something to do with electricity. So yeah, say again. It's Brondo. It's what plants crave. Yeah. So whenever you are now RF current, that's an interesting one because radio frequency, or radio waves, just like electricity, also uses waves, right? I mean, it's in the name radio wave. So, okay, radio uses waves as well. So, just like electricity, if you, for instance, put a brick house in between me trying to transmit and somebody on the other side of that brick house trying to receive, that house is going to cause resistance as well as break line of sight, which we'll also get into, for those waves. And then eventually you're not going to be able to hear anything because those waves are all out of energy by the time they make it through the house, or if they make it through the house at all. So all those choices are correct when opposed by resistance. Wire metals, generally good conductors of electricity. There's really no way to easily remember this other than they have many free electrons. Some metals do have a high density, others do not. For instance, I think tin could be easy to bend. That's not a very dense metal. Aluminum's not a very dense metal if you've ever worked with aluminum foil. And many free protons. That's just gibberish. And obviously all of those choices are not correct, so they have many free electrons. Whenever you need a material that does not conduct very well, let me ask you guys, why do you think you'd ever need that? Yeah, so you don't zap yourself if you're troubleshooting your radio. If your radio is smoking and making weird noises, then yeah, you would need something that does not conduct very well. And these are insulators. Insulators obviously have high resistance. Glass is also a good insulator, just like rubber. Copper, we know, is not a good electrical insulator because, like RJ45, yeah, right, we steal copper wire from houses. So, for instance, RJ45, as a series of cables, those are, we often describe those as copper wires. So that's a good conductor, so that wouldn't be the answer. Aluminum, probably not. I don't know what would happen if you try and conduct through aluminum. I've never actually seen circuits made out of aluminum, but
Old houses have.
do they?
Yeah, it heats up, it expands too much.
Okay, so I'm hearing that old houses have aluminum wiring. It causes the aluminum to expand. I can imagine that would be problematic. Yeah.
Mostly used in your fires.
Yeah, lots of fires.
Mostly used in the service to the home itself.
Okay.
So what you have sticking out of the house into your power panel is just like one big aluminum rod, and then it splits out to copper.
Okay. But I imagine they're not used in houses anymore.
Only for service.
Service?
A lot of the problems that they have with the aluminum wires
Okay.
in normal, in circuits where you turn on and off,
Yeah.
heat and expand, expand and contract, and it tends to start sparking.
Yeah, and I imagine especially if you heat and contract, if you contract and expand metal too much, eventually it'll become brittle. Yeah. So, or
Problem with aluminum though is it starts the insulator, the wire insulation on fire.
okay, so aluminum also starts and also I appreciate you guys backing me up on this. If you do know more than me, call it out. But yeah, aluminum also starts the insulator on fire. I imagine even if you have like a good shielding or some kind of coupling around your wire and the wire expands and contracts and expands and contracts, I imagine eventually that'll also weaken whatever coupling or shielding you have, if it's made out of plastic or PVC or whatever the hell. So obviously that's not the answer. Mercury, no, that just doesn't make any sense to me at all because once it heats up, it becomes liquid. So yeah, that's just silly to me. So glass is the answer. Moving on. Formula to calculate voltage in a circuit. This is one of the few questions on this test I would recommend just staring at until you remember the formula. A, because it's going to be on the test. B, it's just kind of one of those good things to know for calculating out your ham shack, how much power you want to send through, how much resistance you need to put in place. Or even if you're trying to do what I'm doing or Privileged is doing and hardware hack, knowing this formula, you'll use it. I use this formula every single day. So voltage equals amps times resistance. That's it. So E equals I times R. Yeah, that's the best one I could recommend to just stare at until you got it. So once you memorize E equals IR, or E equals I times R. So this is kind of where you can get a little fucky with your algebra. So for instance, if you know algebra really well, you know to move the R over to the E. You can divide both sides by R. That'll cancel the R's out. And now you've got I equals E over R. So that's kind of where it pays to remember middle school algebra or something, as far as taking variables or numbers and figuring out how to move them to the other side. But if not, and that's not your jam, then yeah, you can just do that. So if you can remember E equals I times R, then you'll also get R equals E divided by I. If that's tough to remember, just remember like the REI co-op or something down in Tampa where a bunch of honkies go to get their camping gear. And I equals E over R, which I was able to reverse engineer right here by taking E equals I times R. So if you can remember E equals I times R, I think you're in good shape. If you can remember I, or if you can remember R equals E over I, what you have to do to one side, or what you do to one side, you have to do the other. So if I, want to move the I over to here, I will multiply this side times I, this side times I, cross multiply, and you've got E equals I times R. So that's about as mathematical as I hope to get tonight. If not, like I said, just stare at it until you get it. I promise it gets better. So moving past all that, what is the resistance in a circuit in which a current of 3 amps flows when connected to 90 volts? So we're talking about R. Who can tell me the formula for to calculate resistance? REI, right? Yep. So REI, that looks like crap. Okay, so we've got a flow of 3 amps. So we'll do 3 amps, 90 volts. What's 90 divided by 3? 30. And the cool thing about knowing these formulas is instead of just staring at this question and saying, okay, I see a 3, I see a 90. I don't know how this works, but whatever the answer to that it's going to be 30, because I did that, and it sucked, because I didn't know the fucking formulas, whatever. I was at DEF CON taking the exam, and all I knew was, okay, I got this answer wrong, so it's 30. And I screwed that answer up every single time because I'd see like a 4 and a 120, and I'm like, oh, that's 30. No, that's 30. And yeah, I didn't get it right, and it was really stupid and embarrassing. So resistance of a circuit, 12 volts, 1.5 amps. I'm sure I'm done talking about this. We'll keep moving on. I equals E over R. I think we'll just move past all that. So we're going to move past that. Let's go to... Okay, let's go to page 11, where we're talking about series and parallel circuits. So...
Math question before we move on.
Yes, sir.
So that formula implies that if resistance is 0,
Yes. Well, yes and no. So,
Unlikely you'll have a circuit without any resistance.
yeah, it'll explode.
Yeah, they always do that, but because like every conductor wiring has some kind of resistance.
Yes.
So like
Yes.
it's theoretically or mathematically, I guess, impossible, or is that just like an incomplete point?
I don't know.
Okay.
I don't know.
Probably off topic.
But, it's not off topic. That's a fair question. So Patsy was asking if resistance is 0, is that just going to blow up the whole freaking formula? And the answer to that is I don't know. I've never worked in a circuit that didn't have any resistance before.
Yeah, I wanted to circle back earlier to what you were saying about the current being pushed.
Yeah.
It doesn't really get actually pushed. It's more the electrons are actually changing place depending on the electrical field.
Agreed. However, I'm retarded, so I went with a metaphor that worked for me. Yes, you are absolutely correct. The electrons are changing position within the whole circuit, but I'm also a fucking 4-year-old, so that's what works for me to help me pass a stupid exam. Good? Okay. No, you are absolutely right, and I hope you catch that question on there so you can just crush the exam, but for idiots like me, I need that stuff to help me memorize that, so yeah, if you don't need that, good on you. So, series and parallel circuits. So sometimes you are going to have a circuit with 2 resistors instead of a single resistor. If something is connected in a series, what do we think that means? Let's think Christmas lights, for instance. So we got a light here. I'll tell you what, let's bring this to networking. So with a network topology, what is a bus network topology? Who remembers this from NetPlus? Okay, what do we got?
Yeah, that's it. You got a line, and that's your main bus.
Yep.
And then everybody basically taps off of that. You remember right? You got a token that goes from one side to the other.
Yeah. So looking at the picture that's in the packet. So you've got a series circuit and a parallel circuit. And if you look at the flow of electricity starting at the positive terminal on that battery, so this, whenever you see this on a schematic or something, that often resembles a battery. And the reason you can tell that that's a battery is it'll tell you what side the positive terminal's on and what side the negative terminal's on. If you see a plus surrounded by a bunch of minuses, you can kind of ascertain that that's a battery. And if it is following a circuit, let's say we've got a resistor over here, resistor over here, and then it closes the circuit and ends at the ground or the negative terminal. Okay, so electricity goes, there we go, in a series. So in which type of circuit is the DC circuit the same through all components, or the DC current the same through all components? That's a series. Just as easy as that. And the reason we know it's a series is if we look at the next page, you will see an example of a parallel circuit. So here, where it's just like NASCAR, and you start off at the starting line, run, end at the battery too. So you start at the battery, end at the battery. With a parallel circuit, there are different paths for the electricity to take. Now, let me ask you this. Going back to this parallel circuit here, I'm sorry, not parallel, series. Going back to this series circuit, do you think at any point in time the current is a different number? Yes. So whenever it crosses over this first resistor, it's going to drop. Whenever it crosses over this second resistor, it's going to drop. But nowhere in this circuit are you going to find varying voltages. Where here, depending on where you are in the circuit, you might have no resistor here and a resistor here, which means now we're dealing with different voltages, right? Make sense? So a series is the same. Series same. And parallel, you can remember parallel because who remembers from like 4th grade math class where you have two parallel lines? Do the parallel lines ever touch? No, parallel lines never touch, otherwise they're intersectory lines. So parallel, you can remember two lines, series, same. Good? For DC power, out of curiosity, while the power is in your walls and coming out of your wall outlet, is it direct current or alternating current? Somebody tell me. Alternating, right? Okay. And then you would need a watt to change it from AC to DC for your computer.
Thunderstruck.
Yes, thunderstruck. Yeah, or dirty deeds done with sheep. Yeah. So you would need watt to turn your, because a computer can't use AC current. What can it? No, it'll explode. It needs DC. It needs direct current. Your cell phone, when it charges, uses direct current. So it'll typically use like a transformer or some, like, we'll call it a power brick or something. Yeah, inverter. Yeah. Something within that plug, like if you've ever looked at, like one of those plugs, you would see that it's often like a big box with a plug standing out of it. You got two plugs here, and then a big box, and then a wire. And yeah, that's what connects to your power supply, or that's what connects to your TV, or that's what connects to your ham radio charger. Within a PC, you've got a PSU. What do we think the PSU does? No shit, Sherlock. It supplies power. But, yeah, right? Do we think also it maybe transforms that power from AC to DC? Maybe. Maybe. Go home and ask it. So,
You're supposed to open them and touch everything inside.
yes, you have to actually taste the PSU to see what it does. Yes, you have to
Understand greatly.
you have to taste it. So, which term describes the rate at which electrical energy is used? Is it resistance? No, because we are using the power. Is it current? No, because as Rob's friend back there reminded me, it is the change in position. Current is the change in position of electricity, where I just think it's a fat guy. So, is it voltage? No, it is not voltage, because that's people pushing the fat guy. It's power. So, term describes electrical energy is used. It's power measured in watts. So whenever you see a, 12, let's say a 10 watt light bulb, that's measuring the power of the light bulb. I answered the question right there. So electrical power is measured in the following unit, watts. So there we go. If we want to measure power, we'll go over to the equation side of the board. Power equals E times I. E is what? E is what? Yep. Oh, voltage. I is current, measured in amps, volts. So power equals voltage times current, PEI. That's all you got to do. So you got PEI, and just like we did with these tricks over here, You can get E, which is your voltage, by dividing power by current. You can reverse engineer it that way. Once you have the equation, you can kind of figure out how to reverse engineer it to get the answer. So how much power is delivered? Okay, so it tells us right there it's looking for power by a voltage of 13.8 volts, direct current. Now, it's kind of interesting that it says direct current right there. Now, if that was important, do you think it would be there? Maybe. We'll find out. And a current of 10 amps. So, PEI, so current times amps, that is 138 watts. Good? Pretty straightforward, right? 12 volts of DC current, or I'm sorry, 12 volts DC current of 2.5 amps. Again, P equals E times I, 30 watts. Again, you want to try and have these written down before you go into your exam. And I used to do this on math tests when I was in math class with one of Trey's best friends. I think Trey went home. Oh, yeah, he's in the office. So Trey and I, we went to high school together. We've known each other for almost 20 years. He's one of my oldest friends. A friend in common that we have is Don Hill, who actually all of us were in the Marine Corps at the same time. Don's still in because he's got Stockholm Syndrome. Trey and I got out. And with these equations, the first thing I do whenever, because Don and I were in math class, and he used to make fun of me for this all the time because I've got the memory capacity of a fucking goldfish, is I'd sit down, and before I'd even write my name out, I'd write out the formulas that I'm supposed to remember. I was literally chanting them to myself until I could sit down, write them down at the top of the paper, and brain dump them. If that's what you got to do, that's what you got to do. All we care about is passing the exam. Now, I'd also throw out, there are 30 questions on the exam. You might get these math questions, you might not. If you miss a couple of them, is it the end of the fucking world? No. No, it's not the end of the world. So, let's keep moving. Okay, we'll skip that math question. That's fine. All right, now let's get into suffixes. So, milli, micro, pico, kilo, mega, giga. Mega and giga, I'd argue, are probably the most important, because whenever you are discussing frequencies, you will see megahertz and gigahertz, and you're going to want to be able to tell the difference. If somebody's an asshole and they give you the frequency to their repeater in hertz, and you've got to convert it on your radio to megahertz or gigahertz, or you've got to figure out what unit of measurement your radio is utilizing. Is it megahertz? Is it gigahertz? That's just something really good to know. I'm not going to waste too much time on these questions as far as milliamperes and units of measurement. That's all stuff that I think just looking at the table and figuring out how to move decimals around will probably do the best. Let's ask this. So if I've got, let's say, 4.255 megahertz. I want everybody to write down on their paper how many kilohertz they think that is. And then we will discuss at the end. Remember, we're changing from megahertz to kilohertz. Okay, so if you are going from mega to kilo, you will move the decimal 1, 2, 3 spots, and you will have 4,255 kilohertz. So from mega to kilo, just think 3 decimal slots. If you are going from kilohertz to megahertz, the decimal point's right here, 1, 2, 3. You've got 4.255 megahertz. Is anybody throwed up on that one? Good? Say again? Math sucks, man. I don't know why I became a hardware guy.
It just sucks for us because we all learned the English units.
Yeah.
We all did metric and easy.
Well, you see, there's countries that have been to the moon, and there's countries that use the metric system. So, say again? I don't fucking know. I wasn't even there.
We did.
We probably did. Okay.
I mean, listen, we had the Nazis. They
Yeah, right. We had a bunch of Nazis in Huntsville, and yeah.
knew the metric.
Okay, so the farad is the unit of capacitance. There are 1 million picofarads, and farads, farads, whatever. I ignore this question if I'm going to be honest, because yeah, you're getting into. Oh yeah, right. Yeah, right. Coincidence? You be the judge. So, yeah, I had to get that one in real quick.
Yeah, we have Faraday's right there.
So if you guys like had a baby, it would be a farad.
He wishes.
Farad, yeah. So, what is capacitance? Who can tell me what a capacitor is? Yeah, whoever said that's right. Yeah, so a capacitor, think of it as a silo for electricity.
That's why you pry them off the PSU with pliers.
Yes,
They have a lot of energy in them.
yes. And then you eat them. And then you're like, why do these capacitors taste like blood? I don't get it. So,
They don't taste like blue?
no, they don't. Those are crayons. Those are different things. Yeah.
That is definitely something the Marine knows.
Yes. I know what crayons and capacitors taste like. So, now if you look on this test or this question right here, T5B08, we don't know what we haven't really gone over what capacitance is or why it's important. Don't flip out on this question because you see a unit of measurement that you don't recognize. Just remember how to move the decimal point around. So from pico to micro, from micro to kilo, from kilo to mega. Just remember how to move the decimal point around. Don't really acknowledge the unit of measurement so much with questions like this because it's just there to throw you up. So now we are getting into decibels. Now, one misconception with decibels is that its existence, you know, if you've got 1 decibel and then 2 decibels and then 3 decibels, you know, and if you subtract 2 decibels from 1 decibel, like that, you can kind of do math that way. But decibels are actually, I don't know if the correct term is exponential or not. Yeah, yeah. It's an logarithmic scale. Yeah. So, wow, you were a math guy, weren't you?
Yeah.
Yeah, okay. So decibels are a logarithmic scale. What do I mean by logarithmic? Is as you go higher up the measurement here of decibels, we'll say that, you know, this is decibels, and we'll say that this is ear hurtness. Yes, it is the good ringing noise. That as decibels get louder, exponentially, ear hurtness also goes up because it is not, 1 decibel would be a baseline, but 2 decibels are twice as loud as 1 decibel. 3 decibels are 3 times as loud as 1 decibel, and so on and so forth. So if you go from 1 decibel to 40 decibels, you're not going up like 39 loudnesses. You're going up, you're not going up 39 loudnesses. You're going up, twice as loud, then 3 times as loud, then 4 times as loud, then 5 times as loud. And it causes that curve on the graph. So, yeah. I would argue that you should know, as far as increases go, from 3 decibels to 6 decibels, 10 decibels. Kind of know it by numbers that you can easily associate with. So, for instance, decibel value most closely represents a power increase from 5 watts to 10 watts. So that is technically a double in wattage. However, 5 decibels doesn't 5 decibels and 5 watts don't necessarily correlate. And the reason that this is important is if you are trying to remember, what are watts measuring? Power, right? That's important. So let's say you don't have a transceiver. Hang on, let me erase some of this shit. So let's say you don't have a transceiver and you're just using a receiver. And it says here on the test that an increase in power to the receiver also results in an increase in decibels, which means the more power I give to the receiver, the louder it'll get, right? Why do we think that is? Circuitry. It's all circuitry. For instance, if you invert the power to a speaker, you get what? You get a microphone. Yeah. If you invert the power to a speaker and you cross your wires, it technically becomes a microphone. So, yeah, actually the CIA used to do that in people's hotel rooms.
Yep.
Yeah, that was the thing they used to do. So,
Not just hotel rooms.
yeah, everywhere. But regardless,
More than one speaker, then one of those is listening.
yeah. So as you increase power to a receiver, it gets louder. That's all you've got to really be able to correlate that with, and that's important because I'd say it's less important because, and I would even say this question's outdated because I'd say 9 out of 10 radios today are transceivers and software-defined transceivers at that. With this radio that I've got here, so this is a BTEC radio, think of it as like the Lexus. If Toyota made a Celica or something, this is the Lexus version of it. So whenever I click this button to turn it on, I am not increasing the power to it. The power is the power. The power is being pulled from the battery. If anything, this is changing the loudness via software software that correlates to a dial, that correlates to firmware. So if you missed this question, I really wouldn't care, but
It's still cool if you want to build your own radio.
yeah, if you do want to build your, and it used to kind of be back in the 50s, 60s, 70s, that was what you did, was you built your own radio. Nowadays, especially with the advent of NAFTA and globalism, radios have become so complex. Like, this radio can do way more than just talk and listen. I can program channels in it. I can send Morse code over it. I can even use something called DMR with a radio hotspot to send ham radio over the internet. And so I can talk to people in Russia, I can talk to people in Australia that I normally wouldn't be able to talk to with that radio. And so being able to build a radio by yourself now is going to require you to learn how to do much more than just solder stuff to a board. You're going to know how to program. You're going to need to be able to solder very, very small resistors, because back in the day, a resistor actually looked like kind of like a grain of rice or something with some wires. You got some stripes on it, and you just poke those through the through holes on a board, solder them in, and okay, cool, you got your resistor. It's in place. Now, a resistor is like a very, very small brick.
Yeah, it's surface mounted.
Yes, yeah, surface, yeah, so SMD is the term, surface mounted devices, and oftentimes instead of soldering, the solder's already present on the board, and then you just use hot air and it would stick itself to the board. Or you'd heat the board up itself and it would stick itself to the board. So as radios have become more advanced, build your own radio has, as boards have gotten smaller and technology has gotten smaller, and as radios have gotten more complex, build your own radio, I would argue, is by the wayside. Unfortunately, government moves at the speed of like the repair rate of a McDonald's ice cream machine. So, yeah, right, they're working on that. So the odds of them taking off these boomer-ass questions, also it's the boomers writing the exams anyways, so not that I'm angry about it. So yeah, we'll just move past decibels. Say again? I do, but at the same time, I'm trying not to like waterboard people with knowledge. I'm trying to, say again? Did you read about the ratios?
Yeah.
Well, then fucking read them. God, the Japanese are weird. Okay, so let's get to electrical components and circuits. I could do this in my sleep. I imagine most of you could probably do this in your sleep. What electrical component opposes the flow of current in a DC circuit? Well, gee, opposes. I imagine that would probably be a resistor.
Obviously inverter.
Yeah, right. It's obviously it's a resistor. What type of component is often used as an adjustable volume control? I would counter, though, that may be the case on physical hardware radios, not on software-based radios. Software-defined radios use different components, but in this case, a potentiometer. It would not be a resistor because we're adjusting volume control, so it's obviously not a resistor. Even though volume is based on power, if you've got resistors in place on the circuit, and, oh, see, Danny.
I'm just going over there where it's less cold.
Oh, okay. So if you've got resistors on the board and you're depending on resistors in the board to control your volume, can you control your volume? No, because anytime you want to go up or down, you've got to rip out or replace repeaters. Yes, and that is dumb.
So technically you can.
Yes, that's just dumb. I would not recommend doing that. And a transformer, what does a transformer do?
It's more than meets the eye.
It is more than meets the eye. Okay, so looking at power lines, they have transformers, right? What do we think they do? Step up, step down? Yes, they explode during hurricanes.
When a squirrel gets near one.
Yeah, a potentiometer. You can imagine that by imagining the potential volume whenever you're measuring potential. So potential could be high, could be low. It all depends on what you want it to do. Electrical parameters controlled by a potentiometer. Do we all understand why I told that story of ripping out resistors from a board? Because technically, going back to whenever we were discussing decibels, volume is controlled by the amount of power that we're sending a thing, right? And if we put a resistor in the way of power, it makes less power, which, less power is less volume. So there you have it with that. With a capacitor, so a capacitor stores electricity for a later date. It could be a battery. It could be whenever a capacitor becomes full, a board does something. Who here's ever heard of a USB kill? Nobody's ever heard of a USB? Okay. So if you ever go on Google, I think you can buy them for like $60 or something. It's a flash drive with a bunch of capacitors on it. And the USB kill, it's got like an iPhone adapter, it's got a USB-A, USB-C, it's got these different kinds of adapters. And whenever you plug it into an electronic device, like a TV, it builds up charge inside that capacitor. And if I've got 50 capacitors on a single board, It just keeps building up charge and building up charge until you have a lot of charge. And then it sends that power all out at once, which does what? Fries the board. If you're doing that in a doctor's office who's charging you $500 for a root canal and you hate them, it's really fucking funny. If somebody does that to your laptop because you left it open whenever you went to go piss, it's less funny, and it makes you want to commit murder. But
From experience?
no. If somebody USB killed my laptop, I'd fucking take them down to the Everglades. But just associate capacitors with the USB kill, that it builds up energy, so the type of electrical component that consists of conductive surfaces conducted by an insulator. That is a really stupid way to phrase things, but that is a capacitor. What type of electrical component stores energy in an electrical field? A capacitor. Okay, that's good. So let me ask you this. If a capacitor stores electricity, what describes the ability to store energy in an electrical field? Go ahead and look at those multiple choice questions and somebody fucking give me their brilliant idea. What could it be?
It's always
Capitans, yeah. Yeah.
It's obviously tolerance, because that's C.
Yes. Yes, it is tolerance. Yes. So as you accept more different intersectional parties throughout society, you are able to conduct more electricity throughout your body. That is a scientific fact. The unit of capacitance is what? Just remember him.
Yeah.
I'm serious. Just remember radar. Remember radar and actually no, don't remember that. That if you ever want to sleep again, yeah, if you ever want to sleep again, just associate Jared with capacitance because of his capacity for love. Unless you're RJ, in which case Jared has no capacity for love. RJ's like, yeah. So just associate capacitance with Jared and his big gaping heart. Yeah, take that how you want. An inductor. So, inductors, let me think of how to phrase this really quickly. So, who's ever built an electromagnet before whenever you were in high school? There we go. Okay, so if you've ever built an electromagnet, or who's ever seen at IKEA, they have those induction stoves. Okay, we've seen those before. So they are coils of wire on a glass range, and the way induction stoves work is they actually, instead of generating heat, they send electrical current through the pot or the pan itself, and that generates the heat. So instead of it heating the environment, which heats the pan, it sends electricity to the pan itself. And it's actually a really efficient form of cooking. I actually really say again.
I didn't know that. That's
Yeah.
actually really fucking cool.
It is, and but
Only certain pans work because they
yes,
have a certain amount of iron content.
yes. So with induction stoves, you like All Clad, for instance, which is the brand of cooking stuff that I use, will work with induction stoves where maybe something that's ceramic won't, because you have to have a specific amount of metal in the pan in order for the induction stove to conduct electricity to it and heat it. So, actually induction stoves are, I would argue, kind of the future, because it really can control the amount of heat on the pan. Where with, yeah, it's more even, and you can really get into the nitty gritty of controlling the temperature down to the individual Fahrenheit or Celsius.
You don't have the problem with the traditional, like, using electricity to make heat.
Yeah.
Where that turns on really, really high and then it turns off.
Yeah, so,
and it turns off.
yeah, I actually have that problem.
You can, it's more like gas where you can get a very fine control amount of heat. that you
Yep,
want.
yep.
Turn it on, turn it off, turn it on, turn it off.
Yeah, because that's like, I rent, and my cheap-ass landlord has a electrical stove, and it's just alternating between burning really hot and heating up the pan and doing nothing and making my food really cold. So It just turns cooking into a game of averages, and it sucks. Would not recommend it. So what electrical component is typically constructed as a coil of wire? Just remember the cooking range. That would be an inductor. And an electrical component storing energy in a magnetic field. Again, remembering an electromagnet, again, that would be an inductor. So an inductor, again, uses magnetism and electricity to create energy. I think I got that right. Yeah, whatever. But yeah, you can just, again, associate, say again?
Stove and magnets.
Yeah, stove and magnets, induction, that's the easy part. Going to batteries. This part, oh, yes, Patsy Poo Poo.
So what does induction actually do in the radio?
Okay, so induction in the radio, so A, it depends on how your radio is powered. B, it depends on, for instance, if you are using a specific type of antenna. So remember how, okay, we'll do some real talk for a second here. So you remember how I was talking how ham radio is half science, half art? The radio itself, I would argue, is the science. You flip the shit on, it works. The antenna is where the art comes in. And that's where, especially if you are trying to do some really cool stuff, like when I was in the military, we used to be in really dense trees. Radio, especially UHF and VHF, which we'll get into, all of that is line of sight, which means if if my radio antenna can't see the repeater or can't have the radio waves propagate to the repeater because there's stuff in the way, or I'm too far, I can't radio, can't do anything. So what we used to do whenever we were in really wooded areas was we'd use coat hangers to make our own custom antennas with some 550 cord, and then we'd essentially yeet them up a tree, and then you'd have an antenna on top of a tree, and now you've got all the line of sight you could possibly need. So going back to with induction and antennas, if you are trying to use an antenna to generate to generate a lot of power, you might create some loops in your antenna. You might create some shapes in your antenna to get it to do specific stuff. You might, if you're using an old 1950s radio, it might use magnetism. It might use magnets in some of the switches to figure out what frequency to use. It might use magnets to figure out what mode it's in, or especially if you're using like an analog radio that has like dials and all that other stuff, it might use a magnet to figure out, or it might use an inductor, and electromagnetism to make those dials go up and down, or to, I guess depending on like where your power source is coming from, if you're using a generator, for instance, a generator uses induction, certain generators use induction, certain motors use induction, and if you are using an induction motor versus, let's say, solar power, that might affect how much power is flowing through your radio. That might affect what kind of power is flowing through your radio, what time of day it's going to work, stuff like that. I really wouldn't overthink it that much, and that's kind of why I hate these questions on the test, because if you're doing shit with antennas, induction makes a lot of sense to know. But as far as knowing it for, well, if you got to solder your own radio, Sonny, or you got to fix your own radio, Sonny, dude, nobody's doing that anymore. Like, I remember I had a butt fang that I bought on, a butt fang UV5R that I bought on Amazon. I accidentally broke off the LCD screen on it, fucked around with how to, like, Rab and I sat there drunk how to fix it for, like, 2 days, and then decided, yeah, this is dumb, I'll just throw this out and buy a new one. That's kind of the state of society that we're in as far as a lot of electronics go, but I'd argue even especially with radios is Yeah, the fix your own radio or build your own radio thing, I don't think that's a thing. Especially if you're using this less as a hobbyist and more as a backups way of like you're only bringing out your ham radio every hurricane season or something. I'd even say less so, but that's just my take on it. Good? Okay, any other questions, comments, concerns, or manifestos? Okay, we are trying to zoom. So for batteries, just read the fucking batteries. As far as ones being rechargeable, I don't think lead acid is rechargeable.
Car battery.
Is it? Oh yeah, that is rechargeable. You're right. Yep. Anytime I see lead or anytime I see acid, I think non-rechargeable. But yeah, you're right. Okay. Okay, nickel metal hydride, lithium ion. I'll tell you what, just with this question, lock it into your head that it's all of the above. Don't even look at the options, just all of the above that one. Which of the following battery chemistries are not rechargeable? That would be carbon zinc. I guess at the end of the day, if you get both of these questions on your exam, you can just look up at the T6A10 question and kind of infer that one. Otherwise, like I said, if you miss it, it's not the end of the world. If you have to get this on the exam, it's not the end of the world. And if this is something you kind of have to guess, honestly, unless you're using a handheld, in my experience, very rarely are you going to use rechargeable batteries that don't come with your radio. Like if you're using a mobile station or if you're using a mobile car station or something, you might hook it up to your battery. You might put the mobile radio in your backpack or something, and that might be how you do it. You'll use a battery that way. But past that, batteries come with your radio, and or you're using a power supply for the stuff at home. That's kind of that. I do really quick, and I think this is going to come up, but I want to touch on this too. So we discussed power and watts. The reason watts are so important as far as radio goes is that the power that you put through your radio directly controls how far your signal goes. And that's actually really important. So for instance, if you've got a butt fang and that thing might put out 5 watts of power, or you've got an ICOM mobile handheld station and that thing puts off, let's say 15 watts of power, your mobile is going to travel farther. Now, that's also not taking into consideration antenna length, the contents of your antenna. Like there's other variables in there, but just for the sole sake of argument, looking at the watts or the wattage of your radio kind of directly has an impact on how far you're able to propagate. Now, that's also important on what power supply you're going to use as far as battery and how consistent is that power supply. If I'm using solar power to directly power my radio and I'm getting, it's a full sunny day and I'm able to put off those 15 watts and then, oh shit, now it's cloudy, I can only put off 4 watts. How is that going to factor into my communications plan? So, moving on. We'll skip diodes. Now, going to transistors, and you'll see transistors in a lot of old radios, just like you'll see it in a lot of old appliances or old electronics back in the day, because the transistor was kind of the methodology that logic was decided. But I think it's Moore's Law. Hang on, let me Google that one really quickly. Is it dead? Well, at the time it wasn't. Yeah, okay. So yeah, Moore's Law, it is dead, but at least whenever the transistor was a thing, an observation that the number of transistors on a microchip roughly doubles every 2 years, and its cost is halved over that same time frame. So what that means is we are able to fit more electrical components on the same microchip for less cost. And eventually, as you progress from the transistor to the chip, whether it's an FPGA or an ARM controller or an Arduino or something, eventually I'd argue the transistor is going to go away. I think we're definitely starting to see that with a lot of modern electronics. The Raspberry Pi is a really good example. IoT devices are really good examples of no transistors. So just kind of keep that in mind. Transistors, if you want to correlate the transistor to a logic gate or a CPU or something like that, you know that, okay, the CPU or the FPGA is taking the place of the transistor, which means it can be used as an electrical switch. The term to amplify a signal, gain, I'd say that's pretty common sense. Which of the following can provide power gain? That's a transistor. Okay, we've made it through a lot of that. Moving on. Okay, now we are getting to circuit diagrams and circuitry. I'd focus on this for a couple reasons. A, I know some of you are really interested in hardware hacking, and being able to read a circuit diagram or a schematic is actually really stinking important as far as trying to understand what it is you're hacking, how does it work, how does electricity flow through it. There was something that I was working on at work where there was a TPM, a trusted platform module, thank you, that was on a circuit board. And if the TPM was working and powered and doing its thing, I couldn't really, fart around on the board like I wanted to. But if the TPM was being underpowered or there was no power getting to it, then the operating system didn't read the TPM. And especially if you're using BusyBox or, like a small IoT operating system, that's kind of a way that you can bypass TPMs. Does it always work? No. But TPMs, trusted platform modules, are essentially chips or pieces of hardware that are put on boards that, depending on how they're configured, it allows less to be done with the operating system. There's TPMs out there that might only allow certain signed applications or certain signed pieces of code to execute, which is a really big pain in the ass if you're trying to, put an implant on a computer or something. It could be a really big pain in your ass. It could prevent certain accounts from running with certain privileges, which is a pain in your ass. It all depends, but yeah, being able to read an electrical diagram is also called a schematic. Sure, we're all kind of familiar with that word. It shows component connections. It does not show wire length. It doesn't show what the physical appearance of the components look like. That's obvious whenever you look down at that first figure. That does not show any component that I recognize, so okay, it's showing how they connect. Cool, that makes sense. So if you look at figure TTAC1, and I'm going to kind of hang out here for a bit because I do think this is important. So let's break this down individually. So who can tell me what this is? What symbol is that? It's a resistor. Okay, what else we got here? That's a weird way to phrase that. Okay. Okay, what's this? That's a switch. Nope, it's a switch. So if you look at... Oh, wait, no, okay. That's weird. Why is that listing that as a transistor? That's a switch. Okay, whatever. Okay. No, I'm just basing that. So that's a logic gate right there. Usually, the reason you could tell that something's a gate. Who's confused whenever I say logic gate? Okay, cool. So the reason that you can kind of tell that there's logic going in here. So if you look at one side of a component and it's pointing one side in, and it's got multiple ways out, you can usually say again. Yeah, you can usually tell that there's some kind of logic happening inside of that component. If the ARRL wants to say that's a transistor, it's a transistor, whatever.
Not very common.
Yeah, and to Bosch's point, you don't really see that a lot these days. Again, the test is antiquated. Okay. So, up here, and that is stupid. However, we'll do this. What does this symbolize? Well, it could. They're saying it's a lamp, but I drew the anode and the cathode down there because in today's day and age, it is an LED. You're not going to see a lamp on a freaking circuit diagram anymore. This is so dumb. Who here can tell me what number 4 is?
Battery.
Why do we know it's a battery?
Yeah, a bunch of minuses.
It's got a bunch of minuses. Now, they tried to stump you, which is bullshit. It does not have a plus sign on there, and I think usually every diagram, every schematic I've ever seen has a plus sign on their battery, so that way you could figure out where the positive terminal is and where the ground is. This one doesn't do that for some reason. Out of curiosity, is this a parallel or a series circuit?
Series.
Why?
It's not one after another like a Christmas light. There's 2 paths.
Okay.
I'd say it's not a parallel.
Why isn't it a parallel?
You're saying it.
I would argue it's a parallel
That's what I
circuit.
thought.
Yeah.
Because there's multiple branches in the
Yes. Now, and this is kind of where.
You can't. The whole circuit's not diagrammed.
Yeah.
So you can't say with 100%.
Yeah.
But
Yeah.
it looks like a parallel.
Yep.
This stuff's also really important with DEF CON coming up. If anybody who's into badge life,
Badge life.
this is what you get when you buy those badge kits. You get a circuit diagram and a bunch of parts.
One thing I kind of want to do, and this might even be for my own sanity, is to find a badge that I've picked up at DEF CON and maybe sit down and diagram it out. So that I think that'd be a good exercise to do, especially if you're trying to get into hardware hacking, is to just sit down and map out, especially if no documentation exists for that badge, which it might, it might not. If you're buying an AndXOR badge, which those are really cool people, those are the guys behind Snacky, if you know what a Snacky is. I know they don't map their shit out. So that could be a really cool exercise to do.
The Darknet badge every year, they have the circuit diagrams and everything step by step. And
Yeah.
It's a fun exercise.
Okay. So what is the one thing I want to hang out on really quickly? What is the function of this logic gate or this switch? If they want to call it a transistor, it's a transistor, but it's a logic gate. What do we think the function of it is?
And or.
Well,
in this case, I guess.
so it controls the flow of current, is kind of more what I'm getting at. So with these switches, just like DM said, it could be a OR switch, which that's the symbol for OR. It could be an AND/OR. I can't remember the symbol for AND logically. Actually, I think it's the ampersand, which I can't draw an ampersand because I'm an idiot, so. But yeah, so it's essentially controlling the flow of electricity throughout the board based on certain conditions or principles of what's going on. It might rely on a physical switch. It might rely on LEDs being lit. It might even rely on software. There an FPGA, there are switches out there. There are chips out there. There are CPUs out there that might rely on software to do logic decisions based off of how high the current is, how low the current is. I was talking earlier, I'll go off on a rabbit trail really quickly about LVDS, low voltage differential signaling. I was talking about that in Discord earlier. And the thing with LVDS, and hopefully this touches on this. So noise on a radio, okay, so you've got a line right here, and let's say that's 2 amps and 3.3 volts. That is the correct setting of what's supposed to be going down this line. And then it gets hit with noise. Let me ask you this. What can reduce voltage on a line? We were just talking about it. Resistance. Very, very, very good. What can add voltage out of nowhere on a line? Noise. Noise. Yeah, noise. So whenever you get noise on a line, and let's say if the distant end picks up 4 volts, that equals A. If it picks up 6 volts, that equals the character B. Because remember, we're talking about the OSI model. I'm going down a rabbit trail, I'm sorry, but I gotta do it. So we're talking about layer 1 of the OSI model, right? Where the physical component, the physical layer of the OSI model, all that is just electricity, unless you're using fiber optics, in which case it's just flashes of light. Yeah, it's just flashes of light, but whatever it is,
it's all signal.
yes, you are turning electric signal into data, and then data into information for your stupid ass to read, unless you're watching porn or something, but whatever. So if the distant end picks up 4 volts from this line, hang on, I'll keep it at 3.3 volts. So we'll say if it picks up 1.25 volts, that's an A. If it picks up 1.30 volts, that's a B, and it just keeps climbing up by 0.05 volts until you get through the whole alphabet and numbers, right? So I've got a signal going down the line, and let's say it's 1.25 volts. And it's going down the line, and I'm beginning to type out the word asshole, to call somebody an asshole or something. Going down the line, and then it gets hit with noise. So noise increases voltage, right? So what do you think that's going to do to the message? It's going to garble it. Yeah, it's going to scramble it. It's going to garble it. And so the distant end might see the noise turn 1.25 volts into 2.25 volts, which might be a W.
So it goes from asshole to like face roll on the keyboard.
Yeah, yeah. And so because of that noise, the voltage is being stepped up, and now you've got a problem because the distant end doesn't know what the hell is being said.
Which is why we insulate her.
Yes, that's why we have insulation. Also, you also run the risk of, let's say you've got a fuse, and that fuse will pop at, so if this can take 3.3 volts, with a 2% margin of error, let's say at 3.5 volts, that fuse pops. And now your system's useless until you replace the fuse. Because if let's say you just keeps getting hit with more noise, and you've got 4 volts traveling down a line that's going to hit a system that agreed that it's only going to do 3.3 volts. Do you think that's going to cause a problem? Oh, hell yeah, that's going to cause a problem. So low voltage differential signaling is actually, instead of counting, okay, 1.25 volts is going to be A, and 1.3 volts is going to be B. No, it's going to go off of high and low. And because it is differential signaling, there is often 2 pairs of wires. And so if one line goes high because of noise, and this line stays the same, do you think the distant end is going to recognize that as a bit switch? Nope. Nope, not at all. It is not going to recognize that as a bit because it needs both to go high and one to go low at the same time. And depending on the system design and depending on the architecture, it might agree that low is 1 and this right here is a 0, or the other way around. Depends on the system architecture. But if it's looking for 8 characters or something, so okay, we've got 1, 0, 1, 0, 1, 1, 1. So 1, 2, 3, 4, 5, 6, 7, 8. Oh, yep, okay, there we go. There we go. Now we got 8 bits right there. So if this goes high and this goes low, okay, then that's an agreed upon thing. But otherwise, it needs both of these to be in sync with what's called a clock in order to agree upon signaling. So if this gets hit with noise every single time, but it's all happening in sync, is the distant end going to care? No, because it's high. I don't care how high, but it's high. So that's all I need for it to happen. So things like Cat5 cables actually use low voltage differential signaling in order to A, rule out noise, and B, kind of have an agreed upon thing. But that's completely irrelevant to ham radio. That's just kind of a cool thing that I was running my big stupid mouth about. Moving on past electrical components. The component 8 in figure TTAC2. Let's take a look at that one. Oh my god.
Yeah, their diagrams are awful.
Their diagrams are fucky. Okay, I'll be honest with you on this one, guys. This might just be an idiosyncrasy of the FCC and ARRL who wrote this stupid exam.
Yeah, this is not.
Yeah. Yeah. So I guess at the end of the day, these guys are hobbyists and they're not engineers, but that is certainly not a diode. Do your best with this one to just try and, like you're in first fucking grade, match the correct letters to the correct shapes or whatever. Some things I do think that, might be common. So figure TTAC2, component 9. Let's take, okay. So that's blatantly obvious that component 9 in figure TTAC2, that's a resistor. I think we could kind of agree that that's a,
Yeah, they call that a variable resistance.
yeah, so, but it's a resistor nonetheless. That's fine. Yeah. Let's see. What is it saying figure 4 is? Or is it not? Okay. And okay, so that's an antenna. Or no, that's figure 3. Okay. If you look at figure TTAC3, you'll see an antenna. You'll see some inductors. Okay, so those are 2 OR gates with an arrow. That's weird. Whatever. Okay. I will say figure 4, that actually is an antenna. That should be kind of somewhat obvious here. What do we think TTAC3 is? So if there is an antenna and a bunch of inductors involved, what do we think it is?
You in the forest.
No. So an antenna tuner, and we'll actually go into like why you need to tune your antenna. For instance, if I take an antenna that is built for UHF and VHF, and I try and use it in HF or SATCOM, you're going to have a bad time because this is not tuned for those frequencies, which means I'm either just not going to pick those frequencies up at all, or I'm going to have a very hard time picking up communications. So, moving on. Resonant or tuned circuits. Is this... Not really. Okay, we'll move past these. So I'm going to take a quick break from the packet really quickly and kind of go into some common sense, just as I also kind of see we're on the struggle bus right now, and this is really starting to get tedious.
Might need to be a two-parter.
Yeah, I think this might need to be a two-parter or something, because this is getting a little tedious, and we'll go into kind of some common knowledge really quickly, or what to get out of ham radio. So there comes kind of, once you get your license, and this was really where I struggled, nobody actually told me, like, what do I do? What can I do? So from the technician level, which is kind of level 1 of getting your ham radio license, you'll have access to some HF, or high frequency, VHF, which is very high frequency, and UHF, which is ultra high frequency. VHF, typically, I can't think of the sections of the HF spectrum that you have access to with technician. I know it's really, really small. I know with VHF, you have access to the 144 ranges, and UHF, you have access to the 440 ranges, and these are all in megahertz. Now, out of curiosity, who here can tell me the two frequencies that your Wi-Fi router operates off of? Faraday. You're going to have to actually speak. 2.4 and 5.8 what? Cats? Rontgens?
Yeah.
Rontgens?
No.
Okay. So 2.4 and 5 what? I heard 5.8, but I mean, we'll just say 5. 5 what? Megahertz, gigahertz, kilohertz? Gigahertz, okay. So we can all kind of tell the difference. So for instance, this would be 1, 2, 3, 4. Okay, so gigahertz, megahertz, megahertz, gigahertz. Nice to meet you. These are kind of the general spectrums that you're going to hang out with. Now, this is good and bad. VHF and UHF are, for the most part, line of sight, which means if you cannot see the other person, or if your waves don't have enough power behind them to penetrate through things like buildings and trees and other stuff, which I do want to throw out there, that UHF, out of these two spectrums, are probably the easiest to move through buildings. So yeah, probably the UHF is probably the one I'd use if I'm in my house, or if I'm in a heavily populated area, UHF. But these are both line of sight. Now, there is something out there called the NI4CE repeater. There is also something out there called NOAA. Now, depending on where you live in the Tampa Bay area, you should be able to pick up the NI4CE repeater, and you should also be able to pick up the NOAA weather station. It's all over the place. There's actually, if you're in Holiday, there's buoys off the coast that will propagate that radio signal. So, you know what? Let's try it this way. Let's use a butt fang. Butt fang. Okay, so, oh, hello there. Radio, butt fang. And for the record, for those of you who are ham radio certified and you want to bork around, we've got a bunch of Baofengs at the temple that you can use. If not, and you want to at least pull one out and you're not certified, you want to pull one out and just kind of listen in what's in the area, that's fine too. I will say, if you want to be a cheeky little bastard and transmit when you don't have a license, I mean, is it illegal? Yes. Is there going to be a FUD that chases you down because they have nothing better to do? Also yes. I'm not kidding. There are these retired FUD bastards who have nothing better to do than just sit at home.
They're like the HOA of radio.
Yeah, they're like the HOA of radio, and they will literally get in their 1988 Chevy with like "I hate black people" on the back of the bumper or something, and fox hunt to your house because you either broke a rule and you said a potty word on the over the net, which you're not allowed to do, or yeah, you are not allowed to say potty words over the net. You will get fox hunted.
Yes.
In which case, they will literally use a directional antenna and call up a bunch of their other boomer buddies to try and triangulate your position, find your house, take a bunch of pictures outside of outside of your house because they're on public land, and then report you to the FCC, and then the FCC will fine you. That is a thing that will happen. So,
Make sure you have enough land that you can put your repeater.
Yeah, right.
Where they can't see you from the road.
To get onto your
Yeah,
property.
then you can shoot it.
Now, this right here, with our last little bit of time we have together, so this is a rubber duck antenna. This is a big piece of shit. This thing is terrible. It's like, think of it as like a sliver of copper wire or like a sliver of aluminum or something, whatever they make their antennas out of, and then the rest of it's surrounded by rubber. Big piece of crap. If it's what you've got, it might get the job done, but for $10 or something, you can go on Amazon and get what's called a Nagoya antenna. Nagoya. Much better antenna. It is much bigger. It's got more metal on it, and it's just an instant quality of life upgrade that you can do for your butt fang or whatever handheld radio that you buy.
Do they make adapters for Yagi antennas?
Say again?
Do they make adapters for Yagi antennas?
Sure. Yeah, sure. But let's see what we can pick up with our rubber ducky and a butt fang.
After you're done with this little part, I would like to hear your thoughts on like good entry level radios.
We'll get there. We'll get there.
Beyond the bottom of the barrel butt fang.
Yeah, we'll get there. Now, okay, why do so many people have the butt fang? Let's go on Amazon right now. Oh, fuck no. If you're paying $60 for a Baofeng,
No, it was 60.
hang on. Let's see how much a Baofeng UV5R. How much? $17.49. You can get 2 of them for $32.92. So, yeah. Yeah, now don't get me wrong, like DM was saying, there's like $60 Baofengs. Okay, so actually they have the F8 HP, which is $62. It kind of looks like a UV5R. It's the 3rd gen. It's 8 watts instead of 5. Dual band. Okay, so it's for $62. It's just pretty much a nicer, nicer butt fang. You can also get Baofangs that have bigger batteries, that have more accessories, cooler looking military grade antennas that probably suck just as hard. Yeah, but at the end of the day, these butt fangs, they'll put out anywhere from 5 watts to, I think the current generation is like 8 watts or something. So we could turn this on.
Channel mode.
That is unbelievably annoying. Every Baofeng out of the box comes with this fucking skank talking. So, yep, it'll handle two frequencies locked into it. So the top frequency has, let's play a little game here. This top frequency is 155.700 megahertz. Who can tell me what frequency or what band is that on? Say again? VHF. Very good. Yeah, sorry. Let me UHF. There we go. And this bottom one is 458.725, which is UHF. Very good. Now, let me dig through the packet for this really quickly because we have arrived at some actually really interesting information. Let me find where this is. Because certain boomers will actually a lot of boomers will refer to these bands as like a 2-inch or a 30-centimeter band, and that it's actually on the test too. What frequency is what band? Let's see. Could be. I'm still looking for it. There we go. Okay, so 2-meter band. Is UHF. Oh, wait, nope. I got that backwards. Got it backwards. So VHF, 2-meter band. UHF is, I believe, 30 centimeters. I'll check that one really quickly. Yeah, I think it's 30 centimeters. In the military, we always just said UHF and VHF, where they are getting 2 meters and 30 centimeters. 70 centimeters? 2 meters. Yeah. Whatever. Yeah, so where it's actually getting that is in the 2-meter wavelength. So these boomers actually measure the wavelength of the wave. So yeah, 2 meters, and I think 70 centimeters. Yeah. So VHF 2 meters, UHF 70 centimeters. You might hear those phrases used to describe bands. Just know that they're interchangeable. That actually is on the test, so you could find that and make a note of that. Okay, I've got a brand new butt fang. Boy, oh boy, what do I want to do with it? First thing I'd like to do, especially from a prepper perspective, is find the NOAA.
Because you can look it up on your phone.
Yes.
Yeah.
Yes.
During the disaster.
Well, not during the disaster. No, Jared's actually brought up an interesting point. Yeah, set up your fucking radio before the disaster. You can lock it into the memory. You can lock it into memory banks. You can make a cut sheet. A lot of these modern handheld radios and mobile radios actually have memory banks that you can lock channels into. You can actually, with this little slot right here, so this is actually a data port as well, believe it or not. You can also use it for a microphone. So this is a Kenwood data port. And let me see if there's a data cable in here. I bet you there's not. Yeah, there's not. But what it does have is what it looks like. So this is actually like a piece of crap microphone. However, it's also got this connector right here. So essentially what a data cable would look like is this connector, and then on the other end is a USB-A cable, or a USB-A connector. And you can actually take that data cable, hook one end up to here, one end up to your computer, and use an application called Chirp, or whatever program comes natively with your radio. I use a VM because BTEC is a Chinese company, and, well, yeah, you can be the judge on that one, but yeah, I actually use a VM for loading stuff inside this radio. But however you do it, you can use your computer and that code plug loader to actually create channels instead of having to sit there and fucking, okay, A, B, yeah. Instead of having to do that, you can actually use your computer and put stuff in that way. Yeah, imagine that. But otherwise, you can just, let's see. Say again? I said use Chirp. I just don't have the data cable. So let's say I want to try and find the NOAA weather radio frequency. Okay. So let's try
1, 6, 2.
Oh, I hate that so much. Oh, hold on. I gotta turn that off.
You guys gotta watch this.
Watch what?
The dumpster fire.
Oh, is it good? The debate? It just started? 9 o'clock?
Hell yeah.
Okay, let me finish programming this. I low-key want to watch the dumpster fire. Is it bad? Okay, so one thing you can do with a lot of these radios is on this side, on a UV5R, there's this orange button. And now I'm listening to FM radio. So let's go to 1073. Let's see. That's kind of cool. Yeah. Well, you're listening to the literal radio. Now, what's also interesting about radio, because I'm inside, if I step over here, let's see if I lose it. Yeah. Okay, let's kick it back into regular radio mode. So now I actually have control over, shut up.
1.
No.
And this is how we lost our first battle thing, right?
1.
I'm about to shoot this fucking thing.
Frequency mode.
There we go. Okay, so now we're in frequency mode. Let's try, okay, so we are actually in frequency mode. Let's try 107.300. Oh, you motherfucker. Okay, Baofeng got smart in between the last time I bought a UV5R and now. Sometimes there's software on here that will prevent you from dipping into radio spectrums that you're not supposed to be in. This is one of those cases. Now, I'm not saying you can go on YouTube and easily figure out how to jailbreak a Baofeng to talk on frequencies that you're technically not allowed to talk on. But all I'm saying is if you went on YouTube and there was such information out there, I wouldn't be surprised. 107.3. I was trying to listen to the radio on the actual frequency mode. Okay, so let's try 1, 6.
2, 4, 0, 0.
Let's see what we pick up. Because in theory, let's see if we could pick up NOAA weather radio. Say again? Yeah, sure. We can get the surf report. Oh, I heard something. No, you cannot talk on the NOAA weather radio frequency.
Like the 118 to 137 frequency?
No, no. It's like trying to pick something up here. Okay.
Talk on the CV bands?
No, not on. Well, not officially.
If you do the conversion, you can.
Yes.
I ended up
Not officially.
like Craftsman, Hurricane,
1, 6, 2,
general
5,
radios, and it
0.
Wednesday night.
There we go. Sorry, Aaron. 1 second. Let me turn this down. Go ahead.
It gave you the conversions up to what its channels were to the HF frequency. So when we were driving for a hurricane, there was 2 radios. I grabbed this, plugged in the thing, and I could just talk to them.
Yeah, and to his point, there's different bands. There's GMRS, the general mobile radio thing, and actually Bad Penny, Cam, he's really well schooled on that. Yeah, and
That's what all the G groups use.
yeah, and actually what's really cool about GMRS versus the ham bands is no test, and you only need one person in the house to be certified. And then, you know, like my ham signal is KO4SKN, which I totally didn't pick. That's KO Foreskin. I didn't pick it. The FCC gave it to me. It's like they know what kind of a dumbass I am or something. But yeah, so if I was on the GMRS,
Never forget it.
yeah, I know, you'll never forget it.
Dude, I have to look up mine half the time.
Yep.
I've been on the radio for a
Nope,
while.
I actually, whenever I tell people, like whenever I'm calling into a station, I literally have to resist from saying KO Foreskin. Because I've done that once and then I had to jump off the line because it's like, oh shit. But yeah, if I were on GMRS and my wife were using GMRS, I'd be KO4SKN, she'd be KO4SKN1. So there's kind of different ways you can divvy that up, and like DM said, no test, but yeah, you still have to get, you essentially just like,
Pay $30
yeah,
and give the FCC their blood money.
yeah, so pay $30, get the GMRS license, there you go.
Formation chance through 7 days. Low, 30%. Eastern tropical Atlantic L95. A tropical wave located.
So yeah, there's that. And then I'll tell you what. What are you listening in on? 162.550. You want to go to 161.5.
The GMRS is also really,
Let me know when you're plugged in.
because it gives you a lot of distance.
Okay. So for instance, since Bosch is over there, you know, Aaron's over there with the radio, I'm right here, I could key in and say, any station, any station. This is Kilo Oscar 4, Sierra Kilo November, calling CQ. And he heard it right over there. It works just like any other walkie-talkie, but if I were down the road, it still works. If and there is also etiquette. I can't just key the radio and say, hey y'all, this is Coach East, what's going on? Who's at Popeyes right now? No, can't do that. There is a radio etiquette to talking on the radio. With that said, don't let the radio etiquette or because that was actually something I was kind of lightly terrified of, because in the military, if you're using a radio and you say repeat over the line, for instance, you'll get your ass beat. because they think if a ARTI unit is on station and they hear the word repeat, they'll think that that means fire the same coordinates again. Mind you, like your NCOs will beat your ass even if there's no ARTI units in a 50-mile radius, just because it's an excuse to beat your ass. But yeah, that was kind of something I was a little nervous about whenever I first got my ham license was, you know, am I going to get yelled at when I get on the net? Am I going to get made fun of or something? Just get out there, especially if you say, like, this is my first transmission, and you mess it up. Somebody nice will correct you, or you'll get an asshole. But either way, somebody will correct you. Alternatively, also,
So you could fox hunt them.
yeah, or if somebody's an asshole and they swear at you, you could fox hunt them and then beat them with a bat or something. If you go to NI4CE, if you go to their website, ni4ce.org, you will also find all of the locations of the repeaters as well as their frequencies and where they reach. So, for instance, I might be able to see if I can reach Riverviews from here. So, let's try 442 550. Oop, somebody's talking. They all sound this fucking goofy, by the way. They like, I bet this guy's about as stupid as he sounds. Yeah, so yeah, so yeah, they don't make it. Yeah, so there's a couple. There's definitely the big stick that you can call into. If I'm lucky that I live by a couple of other temple members. One of them I know has a ham shack. Now I know you have a ham shack. So, you know, say again? Yeah, so if you know you live by temple members, get on Discord, say, hey, who wants to jump on the net? Jump on the net, cut it up for a little bit. You can listen to the FM radio. You can listen to Hurricane radio. One thing that's actually really cool, and I didn't know this until I just decided to listen in, is whenever there's a severe weather report or a severe weather warning, hail, like thunder, whatever, NI4CE turns into what's called Skywarn, where there's actually people out there around the county or around wherever the net reaches, and they're saying, you know, somebody decides to lead the Skywarn net. Usually that's an assigned person, and they're saying, I'm taking all reports. And then you might say over Skywarn, yeah, I've got heavy winds over by my house. And he'll say, how heavy? Well, a tree that's 10 feet tall and so girthy just knocked over in my yard, and it's currently over. So that's some pretty high winds right there. And then he'll actually call that into the National Storm Center in Ruskin, and that will help them understand what's going on with the storm, what's going on with analyzing the storm. It's really cool. Another thing I want to tell you guys about, and I think we'll call it for the night just because, God, is this starting to get dry, and I'm starting to get tired of teaching it, and I'm sure you guys are getting tired of fucking hearing it. And what's even cool about the packets, and what I actually encourage everybody to do, if we want to jump on a Zoom session, if we want to cut it up in the Discord channel, group study. I would argue group studying is probably the best way to do it, especially if you're like me. I don't like sitting there staring at flashcards on an app until they're burned into my brain. Part of why this exam really sucks is a lot of it's just so irrelevant. There's so much irrelevant information, and at that point, it's almost like taking the Sec Plus. You're not taking the exam to learn anything. You're just taking the exam for a check in the box so you can appease the DOD or whatever. So there is an organization, there's actually a couple organizations called ARES and RACES. ARES stands for, what does ARES stand for? Yeah, Amateur Radio Emergency Services. And RACES is a similar acronym. And there's one, Radio Amateur Civil Emergency Service. There's usually one for every county, and surprise, it's led by Elmer Fudd. But whenever there's a hurricane warning or there's natural disaster bearing down, the emergency operations centers for each county will actually pull really heavily from these two organizations. And I've actually personally, during a really light hurricane that hit the Tampa Bay area, I was a member of the Pasco County ARES, and Pasco County had me pack up all my ham radio gear, go to a hurricane shelter, and I actually rode out the storm at that shelter, reporting on what's going on, how full we were, how was the storm affecting us. And then at that point, you actually, once the storm's over, they kind of redeploy you with either a chainsaw team or somewhere where people need updates. And you might be, like I said, with a chainsaw team, you might be with the local police. It all depends who you're with. And that kind of gives you something to do during the storm and after the storm, other than just sit there and wait for FEMA. In addition to that, one thing I want to do is build up the Temple net as far as our group of ham radio network operators. But yeah, as far as the curriculum goes, there are a lot of ham radio study tests out there, or practice tests. Take those, try those. Really make sure you know what you're doing before you go down range and pay the $30, just because, especially now that the exams aren't free anymore, or getting certified isn't free. I think if you go to DEF CON, the Ham Radio Village, I think, told the FCC, happy birthday, and they're still doing free exams, unlimited free exams, and then you just pay $30 for your certification once you get it. So you have that option, but yeah, absolutely find a local club. I know CARS, the Clearwater Amateur Radio Society, where I kind of hang around there. They meet on Thursday nights, which is why I'm not always able to go, and I'd love to spin up another, hacker-based ham radio club, not on Thursday nights. But I know they do ham radio exams the first Monday of every month. They also meet, I think, every Thursday, if not the third Thursday. We used to do some collabs with them. We've had a hard time getting hold of them now, but I might go down there and have them remember who we are. But past that, yeah, sorry we didn't get a chance to make it through all of this. I definitely want to kind of rehash some of this curriculum into less say, more do. But yeah, past that, any questions, comments, concerns, manifestos, complaints? Okay, let's move this whiteboard out of the way and watch the collapse of our country. Thanks, Chris.
Birthday.
Chris? You want to kill the stream? Yeah, there we go. Don't speak?
It's time to say